sorry, head back here. You will be able to see my Gibson VM running. Okay, now I've done a bit of an update, so sudo update. Again, that is in the technical manual. You'll be able to do all that. And all we're going to do now is do a quick download of the system, get the system installed, and have a quick look around. Okay, so let's do that. So I've logged into my virtual machine. All right, it should be called Kevin Virtual Gibson VirtualBox. I seem to have missed the V out somehow, but and then what you need to do is go to the place where you are going to download the Gibson Mainframe Simulator software. So that is https://offensivesec.org/Gibson. And we can just quite simply download the simulator. Now I'm downloading it to my, rather than downloads, I'm downloading it to my home directory. So we just download simulator. That won't take any time at all. As you can see, it's only 3 megabytes in size, and you can download the docs as well and have a look at the docs at any point. Here you go. So there's quite reasonably technical documentation there as to what you can do. This is just a quick technical update, so it's everybody has an idea of what they need to do here. Okay, so now we should have everything downloaded. So I've opened the terminal up. I'll increase the size of that. If I just type ls in order to have a look at what's actually in there, you can see the Gibson package has been downloaded. So all I'm going to do is I'm going to unzip the Gibson package from here. So just unzip. I think I've installed unzip. I will check because it's a brand new fresh machine, obviously. And yes, I have, so that's okay. And from there, what you've got is your Gibson shutdown and startup. You've got a README first, so I would always recommend reading that. You've got requirements.txt, which is part of the Python script, and you've got your setup shell script. So what I'm going to do is I'm going to make this script executable. This is, as I said, this is all in documentation. So I'm going to sudo change command +x setup. Okay, so I've made that executable. So if I just type chmod setup.sh, it will ask me to install all the dependencies, because the setup will install Python to the right level. If it's not there, it will install pip and it will import all the requirements that are needed to run the tool. It will install C3270 and X3270 and a few other tools and clients that will allow you to connect to Gibson, because Gibson actually runs over TCP sockets and web sockets. So let's go with that. And the password. Off it goes. Hopefully this won't take too long. So a really reasonably fast connection. Always important to have cups of tea. So I'm just having a look at this. It's just installing all the libraries, and it's just installing everything that you need to install to get Python 3 up and running on this Ubuntu system. Okay, so I mean, it's saying please go and download Gibson now, but we've already done that. All right, so what we're going to do is we're going to press any key to continue. And that's install Gibson. As you can see, it puts it into a directory called mfsim. Next thing it'll then go off and do is import all the libraries that it needs. And those libraries are Flask, WebSockets, PSUtil. It uses the prompt toolkit, passlib for password hashing, and what else do we have there? Yeah, most of that's all good. Script WebSockets is installed. That's fine. There are a couple of other things it wants to install, so let's go yes, that's absolutely fine with that. And then the next thing it does is sets up the different ports for Gibson. There, and then does a quick nmap scan. Make sure that you do install nmap in order for this to run. If you don't, it may, the setup script I think does actually install nmap as well. And I'll show you the ports that are actually listening now. I already installed SSH and 3389, which is RDP, which allows me to connect to the systems. But as you'll see here, you've also got 2023, that is our TSO connection, the main client connection. We have 8081 and 8082. These connections allow us to gain access through the APIs. We have our web dashboard on 8443. And we also have a connection to IBM DB2 now, Kix, etc. You will be able to access through 2023 as well. Now, there's a few other things we can do here, but we're going to leave it like that. So, hold on a second. I apologise. Okay, so press any key to continue. And there we are, we're ready to go. So what I'm going to do is I'm going to very quickly clear my screen. And this Gibson simulator is on 2023. Here's the process IDs that are actually running if you want to kill them off, or you can just reboot the machine and it'll shut Gibson down. So here's Gibson simulator. So I will type clear there, and you have multiple options. So you can type C3270 and 127.0.01 because it's on the local host, and we'll go 2023. And as you can see, we've got a connection. So it's as simple as that to actually install Gibson and get somewhere with it. Well, that's absolutely fine. But what we're going to do now, so next thing is we're going to log in. So we're going to log in using LTSO, which is the standard login for any sort of RACF, IBM Z type mainframes, or you can type log on applet TSO if you want to be using the full command. And we have a few users that I've added in here. It's very simple to add yourself as a user, so I'm just going to show you the very basics of the system here. So we will log in with IBM user, and we'll use the password sys1, which is the default password for an IBM mainframe. And our Gibson is just a simulated mainframe, all right? But it shows you the sort of time that we're doing this. So it gives you the welcome screen as you would expect, that sort of thing. And from here, we can use standard TSO commands. So if you type help, it'll show you quite a few of the commands that are actually implemented at the moment. So I could type something simple like list user, which is the equivalent of who or who am I. And it shows you that you are the IBM user and you have special access, level access, and you can add extra things to that. Okay, so we'll leave you at the ready prompt. You can clear screen on this. So next thing I can do is the equivalent of a dir or an ls, which is listcat, and that shows you all the files that are in your directory. Your PDS as it's called. So we talk about data sets as opposed to files. We talk about PDS as opposed to directories or folders. And there's no directory structure as such. There's a high-level qualifier. As you can see, my high-level qualifier is IBM user, and I can type another command here, profile, which will tell me that sort of information, such as the prefix is IBM user. Okay, so what other things can we do? At the moment, ISPF isn't particularly powerful. It's not. The reason why it's not particularly powerful is it's not that useful for penetration testing in relation to what we're going to actually be doing. I spend most of the time in TSO, which is the ready prompt, but some of the tools that are quite useful. For example, if you type S, the S system display insert facility, I can, for example, look at logged in users or the APF, some issues with C3270, and then I can exit back out of here. Okay, and we can do something simple such as log off. But what I'm going to do now is look out the ISPF menu. I'm going to add myself as a user, so I can use the rakev command, add user Kevin, and I'll call myself Kevin M. And it's a simple version of the add user command. So I can add the password, I don't know, something simple like that, 01. You can do up to 8 characters of a password. If you try to add any more than 8 characters, I'll come back and say you've only got 8 characters that you can use because it's a simulated. So we're just basically simulating for educational purposes. And Kevin M, for example, you could have 7 characters as your user ID. Now, one of the 2 things we've got options to do is we can create ourselves as special. IBM user is special. Special is the equivalent of root. It's not quite exactly that. We can create ourselves as special and OMVS. Now, these are the only 2 options, short of the password and the add user options, that are here. Okay, but your other options, instead of that, you could have none, and you can go no OMVS, and that will mean that no OMVSs, they can't get to the Unix subsystem, which is just a restricted bash shell in this case. And they also don't have specials, so they won't be able to go into console mode. They won't be able to do anything else like that. So you can actually restrict users in this, and I've restricted the guest user. So if I add myself in here, that's special and OMVS, so which gives me all the access I need. I can log out of there. That's great. You've also got an alt user if you wanted to change, for example, Kevin M's access and change that from special to none. You can do that. You can also change the password from kev01 to kev02, and we'll just do that. There you are. So that's updated. Okay. So what I'm going to do is I'm going to log off, and I'm going to show you that this is using C3270, which this is all written in ASCII as opposed to EBCDIC. Reason why I did that is because EBCDIC, actually, you need to the files are rendered differently, the screens are rendered differently, and it's quite difficult to actually attempt to render the screens correctly. So what I wanted is just to be able to use text files everywhere to run this. Okay, so if I log off there, exiting the production mainframe, and what I'll do is I will shut that down and start something new up. There we go. Okay, if I can also use, because it is EBCDIC, ASCII, I can also use NCAT or NC, etc. 2023, and that works just as well. So if I log on LTSO, as I said, I've just created a user called Kevin, 02, I think, and maybe it was Kevin 01. Our memory's terrible. Give me a second. What did I call it again? TSO. Let's go back into IBM user and show you something else so I can just check it. Good thing is it's really quick to log in. So we are going to go list user Kevin. Yep, we've got one of those. List user Kevin 01. And we don't have that. We have list user Kevin 02. List user star. Pretty much list user right now. List user star. See who we've got. Kevin M. My memory is absolutely terrible. I do apologise. So let's log in with Kevin M. So L, TSO, Kevin M, and kev02, and there we are, logged in. So the user that we added, really simply, we've logged in with. Okay, because he's got special no NVS, he's able to do various other things. So we can also send messages. So we do that with the send command. I send hello from Kev, and I'll just actually send it to myself. And the user is Kevin M, and that is now. And it will say hello from Kevin M. You can also send, so this is a multi-user system. Loads of people can log in at exactly the same time if you want to do that. And you can all send messages to each other. You can all do stuff at exactly the same time. So, it's not just for one person. I do recommend that it's not sitting out on the internet because it is vulnerable. It's deliberately vulnerable. And there are vulnerabilities in the system. So, I will just add this here, IBM user from me, and IBM user is not logged on at the moment, so I can send that to IBM user when they log on. So that is pretty much the command. So when IBM user logs on the next time, they will get that message. So you can leave messages for people if you want to do that sort of thing as well. Okay, so if I go, other things I can do here is I can type console, and this allows you to use some of the console commands. So for example, if I type display time, it will give me some time back. I can also type A, L, which will give me all the sort of running processes, etc. If I type, for example, something that's important to pen testers, display prog, APF, it will tell me all the APF libraries that are sitting on the system. Obviously, it's simulated, they're not APF libraries, but you can play away with this and do some interesting things. You can also start some of the processes. So, for example, I can start the FTP daemon just by typing sftpd. And to get out of that, simply end. Okay, so one of the other things that I wrote this for is because I wanted to simulate OMVS, which is the Unix subsystem. So if you type OMVS, we're there. I can type ls-al, and that restricts me into the Kevin M directory here. All right, I'm not able to get out of that. It's a restricted bash shell, so it simulates ZOS, but it isn't actually ZOS. It's just your underlying Linux subsystem. However, there are a few different things that I've added in here. One of the things you can do is TSO commands and run some TSO commands, such as listcat or listuser. You can you can add extra ones. You just need to update the code, and you'll be able to find that code pretty simply, and it'll be 2 lines of code that will allow you to to just add whatever you want in here. Okay. So to get out of that, all I'm going to do is type exit, and exit will return me to the OMVS shell, which will return out the OMVS shell, which will return me to the mainframe. So let me see, what else can we quickly have a look at? That's just very quickly a look at some of the things we've got. If we clear here, I can also have a look at some of the other commands that we have. For example, rack list. And so these are slightly more complicated commands. But again, you can add any command that you want in. All right, and I'll show you how to do that. And that's one of the important things about this. And we are going to go, let's see, Kevin M and detail, and it gives you some feedback on that. For example, it gives you the user ID Kevin M, it gives you who the owner is, and also it tells you the password status, which is valid and encrypted. Okay, so you can do other things like search all, warning, no mask. Well, if I could actually type properly. Okay, so no entries meet that. Okay, so if I log off again, one of the other things that I just want to quickly show you is the Kix simulation. Now, the reason that I've set up a Kix simulation is really to be able to use a tool called Kixpwn against it. And I won't show you that just now. That's going to be on one of the demos that I'm going to do next week. But Kixpwn really is for exploiting Kix without the proper implemented security. So that's one of the reasons this is here. It's a very simple Kix simulation. So we'll just start Kix, press enter there, and I can type help. Okay, and you can see the CSE and logon is optional. We can look at the master terminal. We can look at the system logs that we currently have, what is being executed, what is running, what has started. So if we go CEMT, anybody who does Kix will recognize these screens. Now this is just feedback, basically from text files, plus a little bit of additional magic, if we can call it that. So I can type CEMT inquire program. Will give me a couple of things back there. Okay, so if I go back to help, I have a few other things. It doesn't do an awful lot, though. To be honest, it's really there to be exploited. But feel free to add. There's absolutely no reason why you can't add extra things into here. It's just Python code. So we'll sign off now, and that'll return me back to the mainframe and brings me back to Kevin M at that point. So if I just log off here, there's lots and lots of things to show you, but one of the things I'm going to now very quickly demonstrate is if I go into show you the directory structure. If we type ls there, we now have a directory structure called nfsim, right? And if I tree -d nfsim, tree installed, so I'll do that. Let's see what install tree, because that's one of my favorite commands. And it shouldn't take too long. Hopefully. Tree -d nfsim. You can see the sort of underlying infrastructure that's there. So we've got nfsim, And under that, we have our file system, pretty much. And in there, we've got a command directory. So all the commands are in there. The users have their own directory structures under F as well. And there's some extra things for the file system because we've got an FTP system as well. So if I very quickly demonstrate the FTP server, which is sitting on 21111 instead of 21. You can have it sitting on 21 if you want. You just need to run it with sudo. Problem is, if somebody exploits that, obviously you're running with root, and it could be a bit of a problem there. So we're going to go FTP 127.0.0.1, and we're going to 2111. And it just says, welcome to the Gibson FTP server. And, I've added a user ID for myself. So I should be able to log in with that user ID. And I have nothing in my directory, really, to be honest. And I'll do more demonstrations on how to use the FTP server. You'll be able to do things that are more relevant to ZOS mainframes. Such as quote site file type equals JES that allow you to do JES submissions. File type site parameters unsupported. Have I? Yeah, I've typed that wrong way around. That's why. File type equals JES. There you are. That's better. And you can also upload SQL as well. SQL file type. Helps if I can type properly, equals SQL, and there's only a few SQL queries you can actually upload, and it will give you a response back on those queries, and it will be able to make changes for you to the system based on those. What I had hoped was to be able to, and I probably will in the next update, is to add submissions, to add commands via the FTP server, because there's nothing to stop me really doing that. I released Gibson before doing that and thinking about that, so I will probably do that sort of thing next. So if you quit that, that's fine. So as I said, the tree structure here has F, and all the commands are held in here. So if I show you some of the commands are in the code, but some of the commands are in here. If you want to add a command, we can just type cdmfsim, cdf, and go commands directory and ls that. As you can see, it's as simple as this. The commands are created as the name of the text file. Right, so for example, setter ops list is the text file, and if I cat setter ops list, the setter ops space list, like this. Again, my typing is pretty terrible. You'll be able to see what the output is going to be on your screen, right? So this means that if you can get access to mainframe, or someone can give you access to mainframe, or can give you screenshots from a mainframe, you can easily add all the commands. But for example, I can add any command I want. I could add a command called Bob, and that would give me some output there. So if I create a command called ver, I'll just show you how to do that. Use quite simply on here, I would type nano and type ver, and I can type something like Gibson v 0.3.2, yeah, 0.3.2, enjoy, Control X. That's it. So ver is saved. I go back to here and just go back 127.0.0.1, .223 and log in to TSO. I'll log in as IBM user this time just to see if my little message was sent. As you can see, that the message that I sent has been actually received, so that will get picked up at any point. But also now, along with all the other commands I've got, I can type ver, and you've got the response. Now, there are a few things in here. There are attributes whereby if in the file you add XXX.XXX.XXX.XXX, it will give you the actual IP address that you're on. There's various other attributes as well, such as username. That will give you the username as a response within the text file. So the text files are really templates for the commands. Yeah, that's that. I think there's something else I was going to show you there. What else could I do? Yeah, I'm just going to log off here at the moment. Okay, so how easy is it to also change? As you can see, there's quite significant logging going on as well. If any issues or anything that's coming up. And I'll show you how easy it is to actually change some of the screens as well. And this is one of the things that I really wanted when I use the Gibson as a honeypot. We can just type more vtam.txt, which is the front screen. That you can see is the screen. Now you can just nano this and edit the screen and make it whatever you want, and it will change instantly, because what happens is when you log in and do a connection to the socket, it reads the vtam.txt file. Okay, so it's very simple to make all the changes and whatever you want to do with Gibson in relation to this. That's it. I think I will probably leave that there. I've got a couple more talks on this sort of thing, and if there's anything else you want to ask questions on, feel free to do so. As you can see, it's simple enough to download the system and run it. There are a bunch of other tools that I will show you that go along with Gibson that allow you to exploit the system. There's an Nmap simulator that will allow you to do that sort of thing. There's a Kickspone simulator. And it's possible to get some of the other scripts and other things like that back. It also will respond as you would expect. So if I do, let me see, nmap minus p50,000, which is where db2 is sitting, and do a minus sv for service, and then add the script or run the script, equals db2 daz-info. Hopefully that'll work. Helps if you actually put the IP address in, doesn't it? So we'll go 127.0.1. It shows you I'm kind of doing it on hoof. Take a little second to do that because it's querying the port. And as you can see, it's come back with db2a. So even though it's not real, it is a simulator. It simulates the right sort of thing. So that is based on db2. I'll just change that GOS at some point, and 0.32. So it responds as expected, which is useful again if you want to hang out there as a honeypot. But as I'm saying, if you are hanging out as a honeypot, I would use another tool that I've got, which is I'll demonstrate another time, called Easy Proxy, which can proxy all the traffic from a standard machine into a sandbox, and make sure that nobody can escape from that sandbox coming back out, which is good protection. Last thing I'm going to show you is just a quick look at the dashboard that we've got here, which is HTTPS. It's just HTTP. 127.0.0.1 colon, and I've put that on port 8443. And password is admin, and admin, hopefully it's correct. Admin, not now. And that's fine. It gives you a map of where everybody's coming from, but if you're on the local system, it'll show you one generally sitting in the UK, because that's obviously where I've created this. But it tells you that FTP is active on port 2111, Gibson's active on 2023, and the browser dashboard's open on 443. It will also give you some recent log entries such as rvary, rack list, and other things like that as well. You can zoom in, zoom out. I have a Gibson IDS tool, which is far better than this. This is just a quick dashboard. When the Gibson IDS tool will allow you to save PCAP files, analyze the PCAP files. It will give you a dashboard. It will basically give you a map of where all the IP addresses have come from, or where all your attackers or your people connecting to your system are coming from. And it will also allow you to do, well, as I said, analysis, but it also basically captures all of the traffic, and it allows you to analyze that and then give you a map as part of the output. So again, it's pretty good. And also it will capture user IDs and passwords. It'll do that in EBCDIC, or it will do that in ASCII. So yeah, I think that's about it. One last thing I will show you so you can move on very quickly with this. Within MFSIM, we have a few different things here. I'll show you the editor as well, because it's quite interesting. I had some issues with the editor. It runs in curses, which I'll probably change. So it's kind of good fun, but it's kind of picky when it comes to trying to walk over a TCP socket. Okay, so in here we have a config file, more config.json. So if you're not getting access to the system for whatever reason, or you can't remember the web admin password, it's in here and you can change it in there all you want. It describes where the VTAM, ISPF, and SDSF files are. It also describes where all the commands are held, so you can change things around if you want to. It also starts up the listening ports, etc. That's one thing. Another thing here is I've created like a rackf.db, but it's GACF, GA, which is Gibson Access Control Facility Database. It's just a text file, and it encrypts through MD5 encryption. So the first time you log in, it encrypts the password. Now you can change it if you want to. I wanted to leave it slightly weak and vulnerable so they can be decrypted, but you can change it to use bcrypt or anything you want. Just change it in the Python code, and it's reasonably simple to do that. That will strengthen everything. Okay, so what I'm going to type now is I'm just going to type more gacf.db so you can have a look at it. And as you can see, here's the users that are in there. Okay, I'm going to cut the stream now. Hopefully that was useful for you, and I will be doing a few more demonstrations of other things that are going on. Okay, so I will I'll leave you now, and I will cut the demonstration and the stream. Okay, and thanks for watching. Here we go. End stream.